Welcome to another exercise for the workbook Statistics, this time focusing on the geometric distribution. Our task in this context here is the probability to pass a statistics exam is 84.13%. Questions on this: what is the probability to pass the exam in the third try? Part B, determine the probability that a student does finally fail the exam, meaning he fails in all 3 tries. Well, we have to think a little bit how to translate this text information into statistics. Thereby, let's directly start with part A. Why do we know that we need the geometric distribution at this point? Because all these questions could be translated into what is the probability that the event we are talking about happens in round X. So in round X, after round X, something like this. And that's an indicator for geometric distribution use. Events happen at a certain repetition. So we're going to use geometric distribution here. We want to know the probability that it happens in the third try, so that the try, the x, is equal to 3. We know the probability of this event occurring, that's the pi here, and that's 0.8413. That was the probability given in the text. So we can simply use the formula, which for events where we talk about equal to, we use the formula pi minus 1 minus pi to the power of k minus 1, k being the event I'm interested in. This can easily be explained. So the event should not occur for k minus 1 times, and then on the kth time, period k, this should occur. Well, here it's pretty easy. So we take this 0.8413, put this here and here. We take the 3, put this one here, and we get as an end result 2.12%. So that someone passes an exam on the third trial is actually only 2.2%. Well, that's already part 1. So let's continue with the second part, the part B. Here, what I want at this point is actually that someone fails. Well, fails cannot be really interpreted in terms of passing in an exam. Not directly. Indirectly, however, it means this person might have passed the exam, but later than the third trial. So in other words, I want to know what is the probability that someone only passes the exam at try 4, 5, 6, 7, and so forth. And this is something I can calculate. That's a probability I want to know. He will pass at a later trial than 3. Well, if it's larger than 4, or larger or equal to 4, that's actually quite a lot of probabilities to calculate. So to make our life easier, we actually turn this around, counter probability, going with 1 minus. Instead of larger or equal to, we go with smaller than 4. Well, smaller than 4 translates into smaller or equal to 3. That's what we can work with using the probability from the exercise text. So we use this part here. And whenever we have probability with x being smaller or equal to, in the context of the geometric distribution, we have a particular function for this. And that's here, this part, 1 minus, in brackets, 1 minus p to the power of k. So the 1 minus in front, that's this part here. Whatever is in those first brackets, that's this probability. That's why for pi we're going to use the 0.8413, and for k we're going to use the 3 at this point. This 3, not the 4, the 3 at this point. Giving us then, well, the 1 and the 1 cancel each other out. Minus minus becomes plus. So we only have 1 minus pi to the power of 3. That's actually 1 minus pi, power of 3, giving us an end result of 0.4%. So 0.4% of all students will finally fail the exam, will not pass this in first, second, or third trial. Well, that's it. That's the whole exercise. So I hope you enjoyed it. I say goodbye and see you next time.